Greetings, scholars. It's Brian again. Hey, we talked last time about the Toulmin model of argument and how to map out warrants. We got to get into it. So let's talk today about induction and deduction, and specifically about induction. Now, I said last time, using these terms specific to general and general to specific, please don't get tripped up by that. I think that that's not a satisfying enough variation for us to use in an argumentation course. We need a more robust definition. So let's define induction as the synthetic process used in moving from particulars to probable conclusions. Okay? It's a synthetic process used in moving from particulars to probable conclusions. This tells us about the data that we're using, particulars, and it tells us about the type of conclusions that we're using, that it's always going to be only probable. Here's an example. I saw 50 cows giving milk, so I imagine all cows must give milk. Now that's based on seeing those 50 cows, we reason to a general statement. Of course, it's not true. Not all 50 cows give milk, because every inductive statement is only probable. It can only do its best to make some ascertaining on that. We're going to talk about three types of inductive reasoning, breaking it down. First type of induction is called argument from example. This examines several specific examples and reasons that what's true for some of them is true for all of them. So anytime that someone uses a particular set of population and says that must be true for the whole population, you've got argument from example. Here's an example. Americans are vulnerable to having their rights taken away because of what happened with Muslim citizens after 9/11. Now they're using one specific subset, Muslim citizens, and reasoning that must be true for the entire population. This is argument from example. Another instance of argument by example, when someone says 90% of Americans are behind the president. So a statistic like that, how do they arrive at those statistics? They don't actually survey 90% of all Americans. They take a small population, they hope that it's a representative sample, they ask of those people, do you support this or that? And then they reason based on that small set that must be true for the entire population. So there again, we've got argument from example and the logic of induction there. Second type of induction we call argument by analogy. Argument by analogy is a series of examples in which they're reasoned to be similar to another one. Now here we're not trying to make a general statement. We're saying this case, and this other case are the same as this other one case. So here's an example. The structure of an atom is like a solar system. The nucleus of the sun and the electrons are planets revolving around their sun. So here we've got a specific example. It's not that everything is like that. It's not a general claim. We're just reasoning that the structure of an atom is like the solar system. So from one particular to another particular. Here's another example of argument by analogy. Someone calls you on the phone. The 10 other telemarketers I have talked to were annoying. You will probably be annoying also. And you hang up the phone. That's the response you get. That's argument by analogy. Your past examples and your past history with telemarketers tells you that that one you're talking to on the phone, that's pretty bad. Now, by the way, small change. If for some reason you had that same 10 other telemarketers and you knew that they were annoying and you looked at your phone and you said, oh, all telemarketers are annoying, well, that's argument from example. That's the first type. So the difference between type 1 and type 2 is whether you're talking about a general statement, all telemarketers, or a specific statement, this one telemarketer. Okay, there's a way to distinguish them. Now, in our induction, we also have to work with cause and effect. So we've got a problem in argumentation that we're trying to figure out the difference between correlation and causation. And I've actually linked some videos that discuss this problem. Basically, in life, we see things happen one after another, and we're trying to figure out what is the relationship between those. And much of the problems in human society are when we try to figure out and we don't know what one thing is caused by another thing. Think about the great controversies in your life: climate change, foreign policy, the economy. All of these are controversies over correlation versus causation. Do we have things that are just happening together and are coincidence, or is there an actual functional relationship between the two? Wouldn't it be great if we had a method to figure out when there's correlation and when there's actually causation? Well, it turns out we do. And that process is argument. Specifically, it's induction, and it's called argument by causal correlation, which seeks to establish a functional relationship between elements. It seeks to establish, is there actually cause and effect? And we do this through examining specific cases. So Jake studies and gets A's in the course. Thelma studies and gets A's in the course. I think that maybe studying is what causes them to get A's in the course. There's induction, there's causal correlation. Think about what we know about cancer. We now understand that smoking causes cancer. How did we figure that out? It was figured out through thousands, millions of individual cases, individual examples in which we observed the relationship and then reasoned that there was a general causation here. So that process, it itself, is inductive. It helps us figure out the way that functional arguments work and how we can establish a functional relationship. So there's our three types of induction: argument by example, argument by analogy, and argument by causal correlation. Next time we'll learn about deduction.